We're going to be getting ready for the first exam, and I'm going to make a series of 15-minute videos that go over each of the chapters that are going to be on the exam. So I'm going to start with Chapter 1 and Chapter 2, and then I'm going to get Chapter 3 and Chapter 4 later. And what I want to do is talk about how I need to show my work on paper as opposed to what I would do on a computer when I'm entering my grades on my math lab, entering my answers in my math lab. I just have the answer, and I wanted to really talk about how that work should look. Okay, so I am going to resize my pen real quick. Pick pen. Alright, there we go. So I'm not going to do all the problems in this review, but I'm going to start with number 1, and then I'll skip around a little bit. And if you see a problem that I did skip that you would like to see the solution to, just ask me and I can make a video or talk to you about that one. In this first one right here, we're simplifying with integers, and some of the work that needs to be shown on paper is our first step right here would be to say that when I've got this double negative right here, this will turn into negative 9 plus 3. So I'm going to write that down as my first step before I get my final answer. And a negative 9 plus 3 is going to be a negative 6. And again, I'm subtracting the values, keeping the negative because the larger number is negative. So when one number is different than the other in sign, one's negative, one's positive, we subtract, and we keep the sign of the larger. Okay, so again, I'm going to focus here not necessarily on the technique, which we've already studied in the homework, but I'm focusing on what the work should look like. It is important to write a little bit more than just the answer here. We're going to be asked to show supporting work for our solutions. Okay, so this step right here is important, and personally I like to circle it to show a little bit of work there, but I'm just kind of giving you an idea of what I might do so you can figure out what would be appropriate for you. Okay, the same thing with this fraction, 5/6 plus 1/3. I know that when I'm adding I need a common denominator, so I'm just going to show that I'm getting one by multiplying the top and bottom by 2 right there. And so I'm going to end up with 5/6 plus 2/6, and we're going to call that 7/6. Another note right here, let me circle my answers. Another note right here is that 7/6 is improper, and it's not going to be necessary by hand to write that as a mixed number. If instead you had answered as 1 and 1/6, sorry, my denominator is still 6, 1 and 1/6, that would also be correct. So I would accept either one of these, but this one right here is totally, it's a really bad star. This one is totally okay. Try another star, just for kicks. There we go. Totally okay to leave it improper by hand. Okay, not a problem with doing mixed number, but I would take either one. Okay, so addition, subtraction, same sort of thing. I'm showing my work, getting a common denominator. In this case, I'd want to multiply both of those by something. I might even show it up here instead of rewriting the problem. So my common denominator in those two is going to be 72, so I want to show that I'm multiplying those both by 9, and I'm multiplying these both by 8. Okay, so I'm going to end up with 27 over 72 minus 8 over 72. And then if I do my subtraction, 27 minus 8 is 19 over 72. Okay, can't be reduced, so I've got myself my final answer. Okay, so again, just showing the work. There's more than one way to show it. Like in this one right here, I wrote right next to the problem, and here I rewrote, and then right next to what I rewrote. There's going to be more than one way that's appropriate to show work, but some work does have to be shown. Okay. Let's see, what kind of work could I show here? Okay, in this one it's a multiplication, and I actually don't see anything that cancels, anything I can divide out of top and bottom, so my work is, it's going to be positive. I can note that because I see a negative times a negative is a positive. And then really all I need is, let's see, the 28 on top and the 45 on bottom. There's actually not too much I can do in this case. So not all problems have much to show. It's a little bit hard sometimes to decide when it's appropriate to show work and when it's not. So hopefully as we go through some of these examples, you'll get an idea for which ones I do feel that it's appropriate to show a step or two. And in this case right here, there's no cancellation I can show. It's just a matter of multiplying those two numbers together, and we can certainly do that in our head, so there's not really any work that needs to be done right there. Okay, and this right here, we know that as well. We don't necessarily have to write that. I'm just kind of indicating that I'm observing the fact that two negatives make this a positive answer. Okay. Now, it's a little bit easier to get the show work right here because I can show the step that turns this division into multiplication. And then I can show the step for cancellation, that I'm dividing 2 into both of these right here to get me a final answer of 9/25. Okay. And again, I'll skip number 6 because it's very similar to number 5. We're going to flip this fraction and do the multiplication again. Okay, let me look at some of the other problems on this page. We've got some more fractions, and again, common denominators. I would show getting a common denominator for number 7. I would show writing my 3 as 3 over 1, flipping the multiplication here. Okay. On number 8, there's not a lot of work I can show. I can't divide by 0, so I might make myself a note of that. Can't divide by 0. And so my answer on this one, I would just write the words undefined. But it's nice to give a little bit of reason why undefined is my answer. So not a lot of work I can show. It's just realizing I'm trying to divide by 0 is going to give me an error. I can't do that. Okay. So those were single step problems, a lot of them. So they didn't have a lot of work to show, but it is important to show something. Let's get down to some of these order of operations problems. Okay. It's usually a little bit easier to show work here because there are more steps. In this first one, I would show the subtraction first in the parentheses. So I would show my -3 to the third plus 10. Okay. So -3 to the third is 27 plus 10 is -17. Okay. So again, that entire line can be typed into your calculator to yield the -17. So just yielding the -17 is not what I want, not enough for your answer. A little bit of that thought process and a little bit of the work is important on a paper test to be able to demonstrate that you understand the process as well as how to get the answer. Okay, I'll skip this one. Let's just check out this one real quick. Subtraction, division, multiplication. The division has to come first in this problem because it's before the multiplication. So I've got my 26 minus, and then I've got 6 times 2. So I'm going to do that multiplication next. So that's 26 minus 12. So I've got 14. Okay. That one I wanted to just as a reminder that multiplication and division, whichever one comes first in the problem, is the one that you're going to actually do first. So I just want to make sure a reminder on that right there. Okay, and a reminder again, let me skip down to these two, just as a reminder of properties of exponents with negatives. When I see something like number 16, that's in parentheses, that -5 squared, that means I'm taking the -5 times the -5, and so 2 negatives, and I know my answer is 25. Okay, so again, I've got a little bit of work here to support it, realizing the fact this is 2 negatives. My work on this one would be something like I've got a negative and my 5 squared. The negative does not repeat, which is why this one is -25. Okay, what's being squared in this one is just the 5. Right, so just the 5 gets multiplied by itself. Keep the negative outside for that final answer of a negative 25. Okay. All right. I think I will skip the last couple order of operations problems and move on to the next page. This page, you want to evaluate the expressions. Okay, so again, my first step to show my work would be to write the expression down with these numbers plugged in. So x squared, I'm going to write -2 squared plus 3 times -2 minus y, which is -1. And again, we're going to follow order of operations. So we're going to start with our exponents. Negative 2 times negative 2 is positive 4. I can go ahead and do this multiplication at the same time. 3 times a negative 2 is a negative 6, so I'll just write minus 6. And I can also go ahead and simplify those two signs at the same time. So I'm going to say plus 1. Okay? Equals, and then I'll just finish it up. Okay, so equals negative 2 plus 1 equals negative 1 for my final answer. Alright, so I wanted to show this one to talk about, again, this is a multi-step problem, and I want to compare this with the one where I had something like just had a number minus a negative number. And so in that one I circled these, I wrote my plus 1, and I was careful about showing my steps. When I have more steps like this, I do want to be able to show what's going on, but I can show them a little bit quicker. Again, right here, I did not need to show my work by writing the negative 2 times negative 2. Wouldn't have hurted to do that, but again, this is a multi-stepper, so I can say I got my 4. I've already shown that I can display how to do that in the simpler problem above. In a problem like this, I can go right to that 4 and then keep going with that. So I hope that makes sense. If you have a question about what kind of work is necessary in a problem, ask, or I mean, if you're in doubt, you can go ahead and write down the extra step just to show it, but this is sufficient for this one right here. Okay. Alright, let me move on and check out the next one. Okay, determining if something is a solution to an equation. Let's do this one. Okay, so I start with 1/5, and then I've got 3 plus 2 equals 1/10, and again I've got my 3 for the x plus 3/5. Okay, now when I'm showing the work for this one right now, I'm trying to figure out if they are equal. So I'm going to simplify this side completely, and then I'm going to get my conclusion. So I've got 1/5 times 5, and I want to know, is that equal to 3/10 plus, okay, this right here is 3/10, right? 3 times 1/10. This right here, I'm planning ahead right now. I know I'm going to have to add it to 3/10. So I'm going to write that as something with a common denominator of 10. So I'm going to write that down here as 6/10. Okay, so what I've got right now, go over here for a bit, I've got 5 times 1/5, which would be 1. I want to know, is that equal to 9/10? 6 plus 3 is 9/10. And so the answer is going to be no. Okay, so I'm showing my work, just kind of giving us an idea again of what that's going to look like in this kind of situation. Alright, now we're looking at some problems that involve simplifying an expression. Okay, to simplify an expression, sometimes there's going to be a distribute that I need to do. So I'm going to show my work for this distribute right here. Writing down 8x minus 4 minus 15x plus 25. And then I'm going to add my like terms together. So I don't need to write my little lines right here to group them, but it can be useful just to say these two group together, these two group together. It's a tool I like to use when I'm starting out an assignment on this kind of section, so it could be a useful tip. I'm going to combine the 8 and negative 15 to get negative 7x, and then I'm going to combine the negative 4 and the 25 to get 21. Okay, and then that's my final answer. Okay, so if I did not have those lines, but I had everything else, I didn't have any of these little arcs I drew, but everything else, that work is shown. So I'm going to do this one over here, and I'll try not to draw my lines to see what it would look like without them. Okay, so 2x. Okay, 2 times negative 4 is negative 8 minus 2x minus negative, so that's actually going to turn into plus 1 because I had double negative when I distribute that. Okay, and again, when I simplify this, I'm thinking 2x minus 2x, that's actually 0x, no x, so I don't need to write any x. Then I've got negative 8 plus 1, so negative 7. So this one's going to simplify simply to negative 7. Okay, I'm going to end here on the first video. The next video, we're going to start with the translations, translating things into an expression and then simplifying.